viewers, Yanni, and today in Homemade Science, I'm back with my air cannon shooting more eggs to test an idea that was suggested in previous videos. Quite a few viewers wanted to see if there was a difference between fresh, hard-boiled, and frozen eggs. To start, the eggs had to be fit into something called a sabot for them to fit inside the cannon. There was one problem that we had with the frozen eggs, is that they would always crack. All right, now let's go get your ball. Now let's take a look at the air cannon. 6 feet of air reservoir. The ball valve which releases it is right here. In this case, I have a 10-foot long barrel. The egg is placed here, and then a ramrod pushes it into place. Now I'm going to start off with this material called Duratex. Pretty tough stuff. It's actually a composite of aluminum and plastic. Now we shot at it previously 4 shots, and it took 2 eggs to actually break through it. At that speed, the eggs had almost 450 joules of kinetic energy. In these trials, the egg's going to have a velocity over 400 miles an hour. Now let's see what a raw egg does. Now let's try hard-boiled eggs. And here's the frozen eggs. At these speeds, the eggs have almost 900 joules of kinetic energy. That's about twice as much as it was at 300 miles an hour. On the initial impact, it didn't matter whether the eggs are raw, hard-boiled, or frozen. But what about after that first impact? With the raw egg, we see a fine spray. The hard-boiled fragments are much coarser. And the frozen egg is mostly held together. My next test was done with sheets of cardboard. 2, 1. As you would expect, eggs could break through cardboard fairly easily. 3 sheets shouldn't be any problem. Now let's see if a raw egg can get through 10 sheets. We ended up seeing the same results for all 3 types of eggs. Now, of course, at these speeds, a raw egg could easily pass through 3 sheets of cardboard. But what about if they're separated? In this case, the distance in between each sheet is about 5 feet. Now let's try this first with a raw egg. By the time the egg reaches that 3rd sheet of cardboard, it's dispersed enough that it's not even breaking through it. Try it again. We have the 1st sheet breaking the egg. Hits the 2nd sheet with enough energy to break through it, but it doesn't look like much of the egg has reached that 3rd sheet. Now let's try the hard-boiled egg. And here's the frozen egg. With both of these types of eggs, all 3 sheets look pretty much identical. Now previously I found that a raw egg had no trouble punching through 3/4 inches of plywood. This was only 300 miles an hour and the egg went right through it. Now here I have 3 pieces of 1/4 inch plywood separated with a small gap. Let's see if a raw egg can make it through these. With my first raw egg, the aim was off. The 2nd shot didn't make it through the 3rd piece. Nor did the 3rd shot or the 4th shot. Now let's try this again with a hard-boiled egg. So the transition from a liquid to a soft solid was enough to penetrate all 3 boards. Now let's go on and try the frozen egg. Now let's try it again. And it has no problems getting through all 3 sheets. I think it's amazing that something as fragile as an egg is able to do this kind of damage.
So overall, this has been quite a lesson in ballistics. And I would like to thank those people that suggested I try the different types of eggs. But I'd also like to answer the question of why I'm using eggs in the first place.
Back in my classroom, I used eggs for a variety of lessons. One example was designing projects to catch an egg that fell from 5 meters. We've also shown that you can't break an egg by throwing it into a loosely held bed sheet. These guys are throwing it about 75 miles an hour and still weren't able to break an egg. I wanted to test this at higher speeds, but ran into some trouble trying to get the egg to go faster. Shooting it out of an air cannon would turn the eggs into a fine mist. To solve this problem, I designed various types of sabots. I then went back to the original experiment and found it worked, but I knew we could go faster. My next cannon got us up to speeds to about 300 miles an hour. If you look closely, you can see the egg passes right through the sheet and keeps on going. I got the same results when I fired it at a tarp. After showing this, I had several people challenge me to see if I could actually stop an egg going that fast.
I have a nice soft pillow, so the egg's going to...
I tried several ideas, some of my own and some that were suggested.
This nice soft mattress. 1.
I found it was much easier getting an egg up to 300 miles an hour than it was slowing it down. Eventually, I found 2 methods that worked. Another problem that I found interesting is what I noticed when I first started shooting at targets. The flight path was very erratic. I thought it'd be a good challenge to see if I could improve it. Regular guns do this by putting a spin on the bullet. I had to figure out how could I do this with an egg. By changing the design of the sabot, we got it to work. We also ran various tests for distance.
1. Now, as a teacher, I always thought that problem solving was a great learning experience. For me, shooting an egg offered a lot more challenges than if I were simply shooting a golf ball.
I do have one more challenge I'd like to explore. This egg was shot at 520 miles an hour. I was wondering if we could get it up to about 600 miles an hour.
We'll have to see if it's possible. Anyway, I would like to thank you for watching and come back and see me again. Okay, bye.